Hi, my name is Shunit Haviv Hakimi, and I'll be presenting today our work, BebopNet, Deep Neural Models for Personalized Jazz Improvisations. This is a joint work with Nadav, Bhonker and El-Yaniv. Personalized content is all around us. Tech giants such as Amazon, Netflix, and Spotify provide to the users personalized streams of existing content. However, the challenge of generating new personalized content has been examined only rarely in the literature. We propose a novel pipeline for personalized music generation that learns and optimizes user-specific musical taste. We focus on the task of generating symbol-based, monophonic, harmony-constrained jazz improvisations. Our personalization pipeline consists of three major parts. First, we train BebopNet, a music language model that can generate improvisations conditioned on any given chord progression. Second, we collect data from a specific user and train a personal preference metric that reflects this user's unique musical taste. Finally, using BebopNet and the trained preference metric, we use beam search to optimize the generation process to generate personalized improvisations. We train BebopNet using a dataset of well-known saxophone bebop players such as Charlie Parker, Phil Woods, and Sonny Stitt. BebopNet predicts the next note to be played, given some past notes and past harmonic progression, as well as the forthcoming harmony over which the next note should be played. Our neural network begins with learned embeddings for pitch and duration, which are then used to construct the input to the main part of the network that can be either an LSTM or a transformer. The chord is represented using the concatenation of the embeddings of the four pitches that consist it. The output is decoded using the same embedding weights to predict the duration and pitch of the note to be played next. In the second stage, we collect a training set for a specific user and train a personal preference metric. Each user is presented with jazz improvisations, which they are required to rate according to their preference. As the music plays, the user adjusts the meter to display the level of satisfaction to the currently heard jazz solo. Thereafter, we train a regression model to predict the user's taste. Now that we have the personal preference metric, we use a variant of beam search to optimize the generation process. Consider the process on the left. At each step, BebopNet generates multiple options for the next note to be played. Then, we use a personal metric to calculate the user's score for each option and select the best one according to the score. On the right, we can consider a deeper search in which we use the personal metric after generating multiple sequences as continuation options and choose the preferred sequence. In our paper, we also present a plagiarism analysis to evaluate originality. We measure the length of the largest common musical sequence between any two artists in our training set, as well as with BebopNet. From our results, we found that Sonny Stitt referenced himself the most with an average common sequence length of 10.3. The average level of plagiarism for BebopNet lies within the averages of other artists. Now let's hear a personalized improvisation by BebopNet to the jazz standard Cheesecake. For more samples and supplementary material, visit the following website. Thank you for listening.